All right, so this is Workplace and Apprenticeship 20, Section 2.2, okay? Now, we've been talking about graphs, right? Line graphs, broken line graphs, multiple graphs on the same graph at the same time, so you can see different patterns and things. 2.2 talks about bar graphs, okay? So we're going from line graphs to bar graphs. A bar graph is another way to visually represent data. So a graph, a bar graph, we are visually representing data. A bar graph is used to plot discrete data using rectangular bars, the lengths of which are proportional to the values representative. Okay, so what is discrete data? That's kind of a bit of a strange word, maybe one that you don't know what the meaning of that is, so let's take a look. They have this defined on the side. Discrete data. It's data made up of distinct values where intermediate values are not possible. Okay, so we've taken a look at a lot of graphs where the lines could be connected reasonably, right? Okay, so if we're talking about temperature, let's say, temperature. So if you've got the months of the year on the bottom of your graph and you've got temperature on the side and you take points of temperature, you can understand that, you know what, in between July 15th and August 15th when we took these measurements, the temperature probably was somewhere in between where those 2 points are, and it makes sense that we could have checked in between there and had a temperature, right? That makes sense. But when you talk about a bar graph would be like, okay, what's your height versus your height and my height? Now, because we're all separate people, there is no connection between the heights, right? Because you're really tall and you're really tall doesn't mean because, you know, if you measure me in between those, it doesn't mean that I'm going to be really tall, right? Like, there's no connection there, right? You can't really interpolate the data. Remember that word, interpolate? So if they're distinct and separate and one does not affect the other at all, there's no connection between them, we would use something called a bar graph. Okay. Discrete data is data that can only have certain distinct values. An example is the number of students in your class. The answer must be a whole number since you cannot have half a student in your class. So there are restrictions as well with the numbers sometimes. If we're talking about students, we have to have whole numbers, right? Maybe there are restrictions on some things and not others. The bars on the bar graph can be either vertical or horizontal and have spaces between them. Set the scale, label the axes, give the graph a title the same way you would for a broken line graph. So we're going to look at some bar graphs here momentarily. As with broken line graphs, the scale and the starting point of the axis affect the way a graph is interpreted. Remember we talked yesterday about if you have a break in the graph, or if you don't show the whole scale, the graph could look a little funny, could be misleading. Same thing with the bar graphs here. All right, so example 1. So look at this case right here. The 2001 Canadian Census listed the following approximate populations of various cities to the nearest 1,000. Okay, so here we are, Regina, okay, 193,000. Winnipeg is quite a bit bigger, right? Saskatoon is just a tiny bit bigger. Edmonton is huge, Calgary is huge, Vancouver, wow, look at this, that's 1.9 million. Okay, 1,987,000. So that's 1.9 million. Okay, so now there really is no connection between Vancouver and Calgary, really, right? So we wouldn't link the points together. We wouldn't draw a line between them because there's no points in between that would make sense to this question, right? Like, what's between Vancouver and Calgary? Well, let's say Kelowna is between Vancouver and Calgary. So is Kelowna's population exactly between those two numbers? See, that doesn't make sense at all. There's no reason for that. So this would be data that we would display on a bar graph. So this is what it looks like. Okay? So a bar graph, notice that we would still have certain values, in this case it's cities, on the horizontal part of the graph. And of course this would still be the independent variable, really. Like, this is what you start with. You start with a city and then you count how many people are in there. Does that make sense? And so we would have the population on the side here. And then for Vancouver, you would have one bar, the height of which would represent the population. So the population of Vancouver is quite a bit bigger than the population of Saskatoon or Regina. And that's why the bar is larger. Pretty straightforward, right? It's pretty easy. But the reason why bar graphs are so nice is because if you look at this table right here, those numbers, there's a bunch of them that are 3-digit numbers, and you'd have to look kind of carefully to see, okay, how much bigger would this one be of this one? I see 900 and some and 300 and some. This looks like it should be 3 times as large, but I'm not really sure, how much bigger Edmonton is than Regina. I don't really know. But if you look at the bar graph, you can kind of see, right? So, okay, what were the 2 cities that I mentioned first there? Victoria and Calgary. Okay, so about a third. Let's see. Victoria is right here, and Calgary is right here. So look at how this is sort of like a little over 1 square. This is almost 4. So you could stack 1, 2, and then 3 on top, and it'd be almost exact. Maybe visually you'd be able to see that a little bit easier. Okay. Any questions so far? It's also easy to rank the cities as the most popular. Really easy. This one's the most populous. These 2 would be next. Then this one. Then this one. Then these 2 last. So really easy. Instead of looking at the numbers, right? It's easy and quick. Okay, so build your skills. Let's do a question together. A company tracked how new software was obtained and installed on their computers. The results are given in the table below. Draw a bar graph to represent the data. Okay, so I'll help you with this. So we have software installations, okay. These are different, how the software was obtained and installed. And this is the percentage of total software installations. Okay, so which one do you think you're going to put on the bottom of this graph? What do you think you're going to put at the bottom?
It's not related to this, but do you have graph paper I could use by any chance?
Yeah, not right now. I don't know if I have any extra graph paper right now. Just do this in your lined paper, or in the book. Just do it in the book. Just do your best.
Right.
Yeah, just do your best. Same as I do here. So which one's going to go in the bottom? What do you think?
Software and installations.
Excellent. Probably this is going to go on the bottom, okay? So let's do this. Let's draw a horizontal line. And I don't want to write all these words. So let's abbreviate this. IT department. Let's do that one. And you can write them on a slant, sort of like this, right? So the bar is going to go in between. That's going to be the bar there. And let's put on this side, let's put the percentages. Okay? The percentage. Now, you could go from 0 to 100 because we're talking about percent. I think that would be reasonable. You could also go from 0 to about 60 because we don't have anything above 58. So you don't have to go to 100. Is that going to make things look a little funny? Is that going to be misrepresenting the data if we don't use the whole percentage, do you think? You want to use the whole percentage?
I mean, do you want us not to?
I don't care.
I
think it'll be okay. Let's use 100 though, so we get a better look. Okay, so IT department. So that's 58%. So here's 50. And here would be about 60 right here. So let's go. That means the bar has to be this high. Okay. And then you might want to fill it in or shade it in or something like that. So that would be the first bar. And this would be, oh, I'm sorry, I made that. That's 58. Let's make 60 right here. Okay. So this is the tough part when you don't have lines. Okay, we're going to make it as best we can. Now this one, in-house with help from provider, let's go IT and then, IT and then P, provider. IT with provider. So IT provider. And that's going to be a lowly 16%. So here's 25. So 16 is going to be about here. Okay. So right away you can kind of see the relationship between, there's quite a bit larger percent for the first one than the second one, and so on. Outsourced provider, so let's say outsourced OP, and that's going to be 10%. So the disadvantage of going all the way to 100 and maybe not using this space up here is that a bunch of these bars are going to be pretty small. But I think we can do it. And, sorry, what is this? Outsourced to development partner. Outsourced to development partner, ODP. ODP. And what's that one? 12. So it's going to be a little less than this 16 here. Okay, and then other, so let's just say O, other, is going to be 4. So again, it's getting kind of tough to properly represent a small percentage like 4 out of 100. That's pretty hard. But I guess we can kind of see the relative percentages of each of these categories. Isn't that true? Now this would be, we could title this software, because you should title your graphs, installations, I guess we could call it just software installation, or we could do software installation types. Maybe we could do that. That would be a better title. And then over here we're going to say percentage, and we're also going to kind of give the unit. Usually that's a good idea. And then this would be types of installations, or types of installs, let's just say. Okay. And you don't really need a unit there either if you, okay? So let's see, I think that's pretty good right there. I think that's enough. We've got details here, and we've got the bars appropriately sized, okay? Is that pretty basic? Okay, got that? Any questions about that? Okay. All right, so let's do this one together as well. The following graph shows Jamie's height from age 10 to 18. So this is one person, and does that look like a girl maybe? Jamie, girl? I'm going to assume there it could be a boy too, I guess. Yeah, it's about the same. I know Jamies that are boys and Jamies that are girls. So we'll say Jamie is at 10. Okay, you can kind of see her height at 10. Now, it's going to be a bit of an approximation, but it looks like it lines up about here, maybe about 125 centimeters at 10. And what was her, what was she at 18? Her highest point, or what is her maximum height here? That's going to be about maybe 180, I would say. Okay, 180 centimeters. So there'll be questions kind of surrounding this, I'm sure. So what does the next page say? Suggest 2 ways to improve the way the data is presented. Oh, okay. So how could we do this a bit differently? Now notice that they used a bar graph here, which is what this section's about. Is there some connection between the data values or the heights of these bars or the lengths of these bars?
Yes.
So would this be a good graph to use as a line graph, a broken line graph maybe?
Yeah.
So if you took her height at 11.5 years old, that would be a point we could plot, right? So that makes sense. So the stuff that's in between these does make sense. So maybe a broken line graph would show us a little bit better how she grew over time. I don't know, this would be okay too. This is okay. But we could, I would say one of the answers for that one is that you could use a broken line graph. And maybe the other thing, what about you guys? What do you guys think? Other than maybe write this as a broken line graph, how could we do this a bit better? Look at the quantities, look at the orientation of this graph. What would be a little bit more reasonable? Or what's a different way we could do it that would help?
Like a different graph, or just like...
I don't know, different graph? Or, well, we tried the different graph. That's a good one.
I mean, like the bars, you could space them out a bit more.
You could space the bars out a bit more? Okay. Okay. So, okay, you can space the bars out. Anybody else? Do they need to be sideways? Okay, what do you mean?
Well, I don't know, like, I don't usually see sideways graphs.
You don't usually see sideways graphs. That is totally true, yeah. And you know what? This talks about her height. Maybe having the bars in vertical height would actually make it better. Do you think? So I like what you're saying there. I think if we took that graph, maybe tipped it over so that she has her age on the bottom too, right? Because the age is the independent variable, really. At a certain age, you measure her height. So yeah, I would tip this thing over. is what I would do. Okay, so go ahead and take a moment to just jot those two things down there. And then actually go ahead and do B and redraw the graph the way that you think would be better. Okay, so we said a broken line graph, and we said probably the bars should go up and down. So go ahead and take a moment to do that. Okay, so hopefully you had a chance to do this. I drew both the graphs, but in A we suggested that maybe a broken line graph would be good, and I put the age down at the bottom. That would be, I think, better. So again, here's a rough graph. Yours might look a little bit neater than mine, but a broken line graph would show certainly her increase in height over the years. And there's a bit of an increase, between 11 and 12, and a larger increase between 14 and 15. So that could be represented, right, in both of your graphs there. And so here's the bar graph going vertical, because height is vertical. So that might be a better way to show it. And of course, you'd label the bottom and label the sides here as well for both. So one or both of those graphs, if you drew those, would be great. Okay. Here's at number 3, and I'm going to let you guys do number 3. This talks about misleading data. And so obviously we have some bar graph here, but some of the bars are wider than some of the other bars. And that's because there's more than one month represented here, right? And so what I want you guys to do is to take a look at this, and from what you know and from what you see, give 2 reasons why this graph may be misread. And that's kind of your hint here, is the different width of the bars and that kind of thing. Okay, so as we continue this lesson here, we're going to look at working with different representations of data. Okay, some data can be represented using a vertical bar graph or a horizontal bar graph, and it can be shown in a broken line graph. Each type of graph has its advantages for displaying certain types of data. So here's a picture of Mac the moose. All right, so this is in Moose Jaw, just a mere 45 minutes away from where we are right now. And it's the largest moose in the world, although lately in the news, there's a big battle with Norway, and apparently they claim to have the largest moose in the world, so it's a big battle right now. Very, very close. I think we should just give Mac a new rack. Give Mac a new rack. We should pick it somewhere in Moose Jaw, so it can be the largest in the world again. Anyways, so what do we got here? The following table shows approximate populations of Moose Jaw. I was actually born in Moose Jaw, too. Yeah, fun fact. Yeah. From 1980 to 2005. Okay, populations. So this is in thousands. So in 1980, 33,500. In 2005, what does that say? 32,000. Oh, it dropped. Oh, okay. I think it's probably up since then. But anyways, display the data on a horizontal and a vertical bar graph. Okay, so we're going to take a look at both of those. You don't have to do this right now. We're going to take a look at both those in the next page. Which graph is a better representation of the data? Okay, so let's just skip to the next page here. And there they are right there. Population of Moose Jaw over time. Now, which one do you like better?
Horizontal. Yeah, wait. Is this horizontal?
Horizontal is sideways, kind of like the horizon. Vertical is up and down. Vertical. So I think most of us are kind of nodding our heads saying vertical. You like vertical better? Okay. This one is okay, although it's a little bit, I don't know. I like this one better too. This is more typical, I think, more common. So we can kind of see that the population took jumped a little bit from 80 to 85, and then it's been slowly declining. Now again, it's 2019 right now, and so there's a lot of data that we don't have. So we think we like the vertical data better. Whoops. Let's go back there. Okay, so what is the trend in population size in Moose Jaw? Well, besides a small spike in 1985, it's been gradually declining. Okay, but they've spent a lot of money on tourism and some money on Mac the Moose here. So population's probably gone up, drawing people from all over the world, I'm sure, to Moose Jaw. Okay, so draw the data on a broken line graph. Okay, let's see what that looks like. Well, here we go. This is a broken line graph. Okay. Now, do you like the vertical bar graph or the broken line graph better? Which one of those do you like better? Which one do you like better?
Broken.
You like the broken line graph, okay? Anybody else?
Broken line graph.
And? Over here? Yeah. Do you like the bar graph or the broken line graph better?
Probably
Yeah, okay, so we're 3 for 3 so far on the broken line graph. I think we'll say that's a trend. Okay, so we like this one better. I don't know if it's because it's more familiar. I don't know if it's because it's just simpler. I don't know if it's because there's like, it's less busy, we can kind of see the numbers better maybe. I don't know. Okay. All right. So there's really nothing wrong with any of them, but there are some that maybe work a little bit better, or maybe seem a little bit simpler. Okay. So draw a broken line graph of the data so that it is misleading. Okay, so now for E, we're going to try and draw a broken line graph so that it is misleading. Now here, this goes from 0 to 40. Okay? How could we change things? Here's the year, here's the population. How could we change things without looking too far ahead? How could we change things to make this really misleading? What do you think?
Numbers in the middle, like don't go by like tens.
Okay, don't go up by tens. We could add numbers in the middle.
Or just do that little spiky thing
Do the little spiky thing
at the bottom of the graph.
at the bottom of the graph.
Yeah.
Okay, so I think I know where you're going with this. You're saying, why don't we choose a very narrow range here for the numbers, right? And let's make, instead of this 0 to 40, let's make it like 30 to 35 or something like that. So let's see what happens. I think that's the way that they've now done this. Oh, look at that.
Oh, I see a
They've got a little spiky thing there. Okay, there you go. Technical term, spiky thing. So they've gone from about 31.5 to 35. And look at this now. Now this looks like we have a serious problem in Moose Jaw. Wow, that's serious. But in reality, right, it's maybe not as drastic as you think, because there's still a whole bunch of people that stuck around in Moose Jaw, even though it's declining a little bit. Okay? Another fun fact here. My dad worked in the Air Force when I was born in Moose Jaw. And he was the one that worked on the planes. He was a metals technician and repaired the body and stuff. And he also made the snowbirds smoke. He did that. That was him. He and his group were in charge of making the acrobatic snowbirds team to make them smoke. So anyways, he always told me that as a kid. Yeah, your daddy made those smoke. Have you ever seen the snowbirds? Or an acrobatic plane team like that? Anybody? Yeah?
little fancy stuff.
It's awesome. This is awesome. Okay, so what about F? What does F say here? Let's just read F together. Where's F? Oh, maybe F is on this. What? Population of Moose Jaw by year. Oh, so I guess this is just another way to display this data that's a little bit misleading, right? Because again, a very narrow range with the bar graph. So yeah, this looks like we've got like Moose Jaw. It looks like Moose Jaw has declined in population by about 80% from here to here, doesn't it?
Yeah.
That's huge, you see. And again, up here, it looks like about 75% of the population is gone. So that is a big deal. This is very, very misleading. Yeah, if you don't pay close attention to the numbers, you might think that, again, there's a real serious problem there. Okay, so build your skills. Another chance for us to get some practice here. I'll do question 5 with you, and then I'll let you off on the rest, okay? So question 5 says, I'm going to make this just a little bit larger for us. It says, given the vertical bar graph below, draw a broken line graph depicting the same data. Which graph seems to be a better representation? Okay, well, I'm going to draw a broken line graph. Oh goodness, that's a terrible line. Straighten out my tablet here. So I'm going to draw my graph off to the side here. And so this is test number. And this is Will's test results. So the same data, which graph seems to be a better representation? So I'm going to go the same scale on everything, from 0% to 100%. So there's 50, there's 75, and so on. Okay, so the first one looks like to be about 68%. 68%, so maybe right about here. So test 1 is here, test 2, and so on. Whoops, there's only 6 tests. But there was 8. Okay. And then, so go ahead and we'll just put these points on here. So for test 2, this looks to be about 52 maybe. So test 2 is about 52. Barely passed that one. Number 3 did a bit better. That looks to be about 75. So here's 75. Notice my little tick marks here are not the same as the other graph, which is okay, as long as it's even. Test 4 is about 87. Okay. About 62. And test 6 looks to be about 81 or so. Okay, so somewhere there. All right. So a broken line graph now, what we would do is we would sort of, well, could we connect these? Could we connect these?
No.
This is a broken line graph. Now, the points in between the ones that we've plotted here, okay, so like, for example, what's his mark between test 1 and test 2? Like, is there a test 1.5?
No.
Is there a test 1.88?
Why not?
Oh boy.
Teaching that.
Okay, so we're running into a bit of a problem with the nature of this graph. However, this is how his test marks are going. So what do you like better? Do you like this sort of broken line graph, or do you like the bar graph? Which is a better representation and why?
For this situation, graphing.
You like the bar graph better. Okay, now I have quite a small space here for the tests, and so those points maybe look a little squished up. So maybe that's part of it. This looks easier to sort of read. Okay, the general trend here went down, and then the next two went up, and then he had a little rough spot again, but he finished strong, right? Okay, so there you go. You can say now which one you like better and why you think it's better. And again, there's no real right or wrong answer here. It's just sort of a what your thoughts are. And here is question number 6. And so I'll let you finish those 2 questions, and then you can look ahead, read the examples ahead, and work ahead if you have some extra time.
Is that all?